Welcome students. We are back with another lesson. In this lesson we'll discuss projectile motion. So what is a projectile motion? A projectile is a name given to any body which once thrown into space with some initial velocity moves thereafter under the influence of gravity alone without being propelled by any engine or fuel. The path followed by the projectile is called trajectory. Now, as you can see in this example, a footballer kicks the football. So he is giving some force to the, say, he is giving some initial velocity to the football. So after reaching to a point, let us say at point 4, the football starts to move under its own motion under the influence of gravity. You can see in this case, which is your 4, 5, 6, 7. In this case, the ball is moving under the influence of gravity alone, whereas in the state of 1, 2, 3, 4, it is moving due to the force applied by the footballer. Right? So once the footballer has applied some force, the body continues its motion without any external influence, or I'll say without any engine or fuel, and it moves only under the influence of gravity. Such path followed by the body is known as your trajectory. Now note, while the body is in motion, let us consider for the phase 1, 2, 3, 4. Okay, let us consider only phase 1. Now when the body is in the state of 1, 2, 3, 4, what you should notice is that the body is moving under the influence of two forces. One is the horizontal force which is applied by the footballer. The other one is the external force which works against the gravity to lift the ball. Therefore, as you can see, the resultant of these two forces leads to a motion in a trajectory path, or I'll say it leads to a projectile motion. Now as the ball moves upward, you can see the force which pushes the body upwards decreases and finally becomes zero at this maximum point. Now when the ball reaches at this point, the velocity becomes zero. Now when the velocity becomes zero, the gravity comes into the picture, which starts pulling the ball in the downward direction. So you can see this small red arrow which is pulling the body downwards, whereas the horizontal velocity is still in the picture. So as the body goes further, the action due to the gravity increase, or the force due to the gravity increase. Therefore, my ball at a certain distance reaches the ground. So again, here are two components of the velocity. One is the horizontal component and the other is the vertically downwards component. Can you see? So in our case, what we have learned, there are two kind of velocity components. One is your velocity upward component and the other one is your horizontal component. After the maximum height, what happens? There are again two components of velocity. One is the vertically downwards component. The other one is the horizontal component. Fine. So using the concept of projectile, let us solve this question. A projectile is fired with a velocity small u making an angle theta with the horizontal. Show that its trajectory is a parabola. Derive the expression for the time of maximum height, the time of flight, maximum height, horizontal range. So suppose a body is projected with the initial velocity u. Fine. Now let us consider this is our body. This body is projected, or this body, it starts moving with the initial velocity small u, making an angle theta with the horizontal. Making an angle theta. Can you see this theta? With the horizontal, which is my x-axis. The velocity has two rectangular components. This velocity u has two rectangular components. This is your one rectangular component. This is your another rectangular component. Now the first one, the horizontal component u cos theta, which remain constant throughout the motion. So this is your first rectangular component, u cos theta, and this u cos theta remains constant throughout the motion. Fine. This value of u cos theta does not change. Second component, the vertical component u sin theta, which changes with time under the effect of gravity. The component first decreases, becomes 0 at the point A, after which it again increases till the projectile hits the ground. Till the projectile hits the ground. Fine. The other component is your vertical component, which is now this u sin theta. It decreases with time under the effect of the gravity, and it becomes 0 at this point A. After reaching this point A, it again starts to increase, but this time in the opposite direction. Fine. So this is your vertical component. Now, first we will derive the equation of trajectory of a projectile. Now, suppose the body reaches the point P, x, y after time t. Suppose this body after a certain time interval reaches at this point. This point is denoted by P, and the coordinates of this point along the x-axis is x, along the y-axis is y. So I'll write this point P as xy. It reaches this point after your time t. Fine. Now, therefore, the horizontal distance covered by the body in time t will be, we know your velocity equals to the distance traveled upon the time, or I can also say my distance traveled equals to velocity times your time. So I can write this one here. Fine. So horizontal velocity times time. Now, since we are considering the horizontal motion, so we will use the horizontal component of the velocity, which is u cos theta. So substitute the value. Horizontal velocity will be u cos theta times time is denoted by small t. Therefore, I can write my small t as t equals to x by u cos theta. Send this u cos theta to the denominator. Fine. So this is the time. Now for the vertical motion, what is the velocity? U sin theta. Fine. Now, as we know, the gravity acts in the downwards direction. So if gravity acts in the downward direction, so any body falling downwards will have some acceleration, which will be denoted by small g. Fine. Now look here. This is our horizontal component, and it is pointing in the upward direction, whereas my acceleration due to gravity is pointing in the downward direction. So what will happen? My acceleration of this body will be negative of my acceleration. So I have written A equals to minus G. So the vertical distance covered by the body in time t will be given by, we know the equation, S equals to ut plus half at square. Now along the y or your along the vertical component, what is the distance traveled? The distance traveled is y. So instead of s, I'll write y. What is the velocity in the vertical component? It is u sine theta. So I'll write u sine theta. What is the time taken? Time taken is x by u cos theta. We have derived, so substitute the value x by u cos theta. Now plus half, you write down plus half. What is the acceleration? Acceleration is minus acceleration due to gravity, small g. So I'll write plus and minus. Here is plus, this is minus, plus and minus will become minus g. Fine. Now t square. T square will be simply square this x square by u square cos square theta. Fine. Now look here. This u and this u gets cancelled. Sin theta by cos theta will be written as tan theta. So I can write this one as x tan theta. On this side, what I'll do, on simplification, I can write this one as g by twice of u square cos square theta x square. Fine. Now let us assume this part as a constant p and this part as constant q. So I can write my vertical motion y equals to px minus qx square. Now the body will follow. Now look here carefully. As the value of x is very small, out of this term, this part, the first part will be dominating first. So for the smaller values of x, that means for up to this range, what happens? My y will be directly proportional. My y will be equals to p of x. Okay. So for the first part, this first component is dominating. So we know this is a equation for a linear curve. That means this should be traveling in a straight line. So up till this point, it should be moving in a straight line. Fine. Now as the value of x increases, for the second half, let us consider what happens. Your second part of the term becomes dominant. Now in this term, this is minus x square. Okay. So if I have to show you the curve for x square, it looks somewhat like this. But if it is minus x square, then it will look somewhat like this. Okay. This graphs you will get in more maths class. Fine. Here we will just use their application. We won't go into much details. Fine. Now as you can see, the second term comes into the picture. So the path starts to follow this trajectory. Fine. So therefore the total path followed by the body will be this part, and this part is known as your parabola. Fine. The trajectory followed by your body, which is moving in this semicircle kind of shape, isn't it? This kind of path is known as your parabola. So using this equation, we can see how our body is moving. It is moving in a parabola. Fine.
Next, we'll discuss about time of maximum height. So, time for maximum height, that means when the body reaches at the maximum position, which is at point A. So how much time is required by this body to start from A and reach at this point A, which is your maximum height. Now, let Tm be the time taken by the projectile to reach the maximum height Hm. Fine. So if this is the maximum height Hm, let Tm be the time taken by the object to reach this height. Fine. So at highest point, the vertical component of the velocity equals to 0. As we have discussed, when the body moves along this part, what happens to your vertical component? It decreases, 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 decreases up till this point where it becomes 0. So at the highest point, what is the vertical component of the velocity? 0. Fine. So we can use our equation of motion v equals to u plus at. Fine. So in this case, what will be your final velocity? What is the velocity at this final position? 0. What is your initial velocity? It starts with the initial velocity u sine theta. So write down u sine theta. Why we are using u sine theta? Since it is a vertical component. We are not considering the horizontal part. We are considering the vertical part. So it is u sine theta. At this point, the final velocity is 0. Fine. Minus then plus a. What is a? A is the acceleration due to gravity, which in turn equals to minus g, and t equals to tm, time taken to reach the maximum height. From here I can write my time taken to reach the maximum height equals to u sine theta by g. Thus this is the time taken by the body to reach the maximum height. Fine. Next we'll find the time of light. What is time of light? It is the time taken by the projectile from the instant it is projected till it reaches a point in the horizontal plane of its projection. That means the time of light means the time taken by this particle. Let us consider this red dot as a particle. How much time does this particle takes to reach back to the ground? Or I'll say the time spent by the particle in air is the time of flight. Fine. Now the body reaches the point B after the time of light Tf. So in this case we will assume the time of flight to be how much? Tf. Fine. Now the net vertical displacement covered during the time of flight equals to 0. What does remember what was displacement? Displacement is the shortest distance between the point A and the point B. Fine. Now let us consider this point. Suppose a particle is launched and then it return back to the initial position, or let us say the particle is launched from the ground and then it returns back to the ground. In this case, what will be the displacement? In this case, the difference between the initial position and final position is how much? 0. So similarly here, the particle starts from the ground, it travels, it spends some time in the air and then return back to the ground. In that case, what will be the displacement along the vertical component? Okay, we are not considering the horizontal component. We are considering the vertical component. It goes up, it comes back down. So what is the displacement along the vertical component? The net vertical displacement, it is 0. Fine. So using our equation, S equals to ut plus half at square. Fine. Let us substitute the values here. What is the displacement? Displacement equals to 0. What is the initial velocity? The initial velocity along the vertical component is how much? U sine theta. So write down u sine theta. What is t? Time taken for time of flight. The time spent in air is how much? Tf. Fine. Write down half. Acceleration. What is a? A is minus of g. T is how much? Tf. So there is a square. Put a square sign. Fine. From here on simplification, I can write my Tf equals to twice of u sine theta by g. This is the time of flight, the time spent by the body in the air. And previously we have discussed time of maximum height, the time taken by the body to reach to the maximum position at this point, and it came around how much? U sine theta divided by g. Now what I want you to do is compare TF, compare TM. Now when you compare your TF and TM, what do you notice? Do you notice this 2 sign here? What is this quantity? This quantity is Tm, isn't it? So I can write my time of flight Tf equals to twice of Tm. So this is expected because the time of ascent is equal to the time of descent for the symmetrical parabolic path. So from here what we have derived, suppose this is the time of flight. Time of flight is twice the time to reach the maximum height. Can you see this red line? Yes. And why is it so? This is so because suppose let us consider this one to be a symmetrical parabolic path. What does a symmetrical means? Symmetrical means say similar shape. Suppose this is a circle, okay? And if I bisect it or I divide this circle into two halves, these two circles will be exactly similar to each other, isn't it? So I'll say this half is symmetrical to the other half. Fine. So similar in this manner, if you have a symmetrical parabolic path, in this case, fine, if you consider a symmetrical parabolic path, the time of ascent means the time to reach the maximum height plus the time of descent, the time to return to the ground, will be same. If these two are same, what about this one? The total time taken will be the sum of this one and this one. That means twice of t, isn't it? So I can write the total time t is half of the time this one. Either it can be a time of ascent or it can be a time of descent. So from here we note a very important point. The time of flight equals to twice of Tm. Fine. Next topic, maximum height of projectile. It is the maximum vertical distance attained by the projectile above the horizontal plane of a projection. The maximum distance, this distance from the ground, is known as your maximum height. It is denoted. So at the highest point A, vertical component of the velocity equals to 0. What will be the vertical component? The vertical component of the velocity at this point, will be there any velocity pushing the body upwards? No. So at point A, what is the vertical component of the velocity? 0. Fine. So using our equation of motion, v square minus u square equals to twice of as, I can find the value of hm. So let's find v. What is the final velocity? Let us consider this one as my initial position and A as my final position. Fine. So what is the velocity at point A? It is 0. So substitute the value 0. What is the velocity at initial position O? It is u sine theta. So substitute u sine theta. Fine. Similarly, in this case, write down 2. What is A? A is the acceleration due to gravity. Since it is in opposite direction, I'll introduce a negative sign. So I'll write minus g. Fine. Now, in this case, how much distance it has to travel? It has to travel a distance of hm, isn't it? We are considering only the vertical component. Again, I'm telling we are considering the vertical component, not the horizontal component. So how much distance this particle has to travel? It has to travel a displacement of how much? Hm. Fine. The distance between the final point A and the distance between the initial point is known as your displacement, which is denoted by HM, or I can also say this one as maximum height. Fine. On simplification, fine, you can cancel this minus from both sides. Send this 2ng to the denominator. I have open the square bracket, u square sine square theta divide by 2g. So the maximum height equals to u square sine square theta divided by 2g. So this is the maximum height of the projectile. The horizontal range. The horizontal range means the maximum distance, the maximum horizontal distance our particle can cover. If it is projected from this point, what is the maximum distance along the x-axis which it can be covered is known as your horizontal range. Fine. Now horizontal range I can write as horizontal velocity times the time of light. Why? Because the total time taken for the particle to move from point O and reach to the point B. How much time is taken? We have derived. It is time of light. Fine. So it will be the horizontal velocity. What is the horizontal velocity? U cos theta. U cos theta times the time will give us this maximum distance which we call as horizontal range. Fine. So horizontal range, we'll denote it as R. Write down horizontal range as R. What is the horizontal velocity? U cos theta. Write down U cos theta. What is the time of light? We have derived the time of light twice of U sin theta by G. Fine. On simplification, u and u becomes u square. Fine. Write down 2 sine theta cos theta divided by g. Now there is a trigonometric property, twice of sine theta cos theta equals to sine 2 theta. So instead of writing this one, I can simplify it further. I can simply write sine 2 theta. Therefore, what will be the horizontal range? R equals to u square sine 2 theta by g. This is the horizontal range. Fine. After deriving your equation of path, your time of maximum height, your maximum height, your time of flight, your horizontal range, we will move or we will use those concepts to solve this question. Determine the condition for the maximum horizontal range. Show that there are two angles of projection for the same horizontal range. Fine. So we have to show or we have to find the condition for the maximum horizontal range. Now we know what is the maximum horizontal range. R equals to u square sine 2 theta by g. Fine. Now get, so what value sine has? Sine has 0. Sine has 1 by 2 root 3 by 2, sorry, 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. These are the values which sine can take. Okay. So out of this value, what is the maximum value a sine can take? Sine can take the maximum value 1. So clearly my horizontal range will be maximum when this value equals to how much? Equals to 1. When sine 2 theta equals to 1. And when my sine theta equals to 1? When it is sine 90 degree. Fine. So using these two relation, I can find the value of theta. So sine 2 theta is also 1, sine 90 is also 1. Therefore, I can write 2 theta equals to 90, or my theta equals to how much? 45 degree. Divide this 90 by 2. So the horizontal range of the projectile is maximum when it is projected at an angle of 45 degree with the horizontal. Fine. So what does this statement means? Suppose suppose this is you. Okay, if you want to reach or if you want to attain the maximum horizontal range, what you have to do, you have to throw the stone at how much angle to reach the maximum distance. How much you have to throw, at what angle you have to throw the stone? You have to throw this stone at an angle of 45 degree. So when you throw this stone at 45 degree, it will go the furthest, fine. So the maximum horizontal range is given by Rm equals to u square sine, what is 2 theta? 2 theta equals to 90, write down sine 90 by g. Sine 90 is how much? 1. So Rm equals to u square by g. So what will be the maximum horizontal range? It will be u square by g. So this is the condition for the maximum horizontal range. Fine. Moving on. Next we have to show that if we throw the stones at two angles, then there will be specifically two angles for which there will be same horizontal range. Okay, we have to show that suppose you throw a stone at some angle and you throw a stone at another angle. Fine, suppose this is theta and this one you threw at another angle phi. So I have to show that there exists a pair of angles in such a manner, like in this case theta and phi, for which the horizontal range, this distance, will be same. For red one also it will be this much, for this blue one also it will be this much. Fine. So the horizontal range of a projectile projected at an angle theta with the horizontal with velocity u is given by, we know the range formula, r equals to u square sine 2 theta by g. Fine. Now in this case, instead of theta, let us replace it with 90 minus theta. Fine. So when we replace this 90 minus theta, you can write u square sine 2 90 minus theta by g. Take this 2 inside the bracket. What I have, 2 times 90 how much? 180. 2 times theta is how much? Minus 2 theta. Therefore my range can be written as u square sine 180 minus 2 theta by g. We know sine pi minus theta is always equals to theta. Fine. Using the same concept here, in this case, how much is my pi? Pi is 180 sine 180. How much is my angle? 2 theta. So instead of theta, you will write down how much? 2 theta. So how much will give this one? This will be sine 2 theta. Fine. Okay. So don't worry. This mathematical part will be again explained in your maths class in your chapter trigonometry. Fine. So for now you just get this concept. Sine pi minus theta will be sine theta. So sine 180 minus 2 theta will be simply sine 2 theta. Fine. So what will be my this new range which is projected at an angle 90 minus theta? It will be u square sine 2 theta by g. So do you notice something? This range was also projected at what angle? That means suppose this is one, you throw a stone at an angle how much? What angle you threw this stone? At an angle of theta. Fine. This is theta. Now you again throw the same stone but at a different angle. But this time you are throwing at what angle? Let us say you are throwing this one at an angle of 90 minus theta. If you throw this one at a 90 minus theta, what happens? The stone reaches the same point. this point. Okay, the stone reaches the same point A. So in this case, what do you notice? The range in the theta case and the range in the 90 minus theta case are both the same. Hence, for a given velocity of projection, a projectile has the same horizontal range for the angles of projection theta and 90 minus theta. Fine. So here I have shown you some angles or some example. Let us consider the first example. If you throw the stone at 15 degree, this is the range. Now what is 90 minus 15? 75. So if I throw this stone at an angle of 75 degree, it has this, isn't it? Similarly, if let us say you threw this one at 30 degree, what is 90 minus 30? 60. And if you threw the stone at 60 degree, it will have the same range. Fine. So this is the graph, or I'll say this is the figure depicting R, which is same for both theta and 90 minus theta. And when will be the R maximum? Just now we have found out the R will be maximum when you throw this one at an angle of how much? 45 degree. So there is only one angle for maximum range. And how much is this one? 45 degree. Rest all of the angles have 90 minus theta pair. Fine. So here I have given the conclusion. When the angle of projection is 90 minus theta with the horizontal, the angle of projection with the vertical is theta. This indicates the horizontal range is same whether theta is the angle of projection with the horizontal or with the vertical. Fine. So here what you notice is if this is theta and you are throwing this one also at how much angle? 90 minus theta. Fine. If this blue component is 90 minus theta. Fine. How much is this angle? How much is this angle? This red one. This red one is 90 degree, isn't it? So how much will be this part of the angle? So this part of the angle will be 90 minus this angle. How much is this angle? 90 minus theta minus 90 minus theta. So when you open the bracket, these two terms get cancelled. Minus minus becomes plus. So you have theta. So what is this portion of the angle? This is also theta. And how much is this projection of the angle? This is also theta. So when you throw a stone at an angle of theta with respect to the horizontal, when you throw the stone at an angle theta with respect to the horizontal, or I'll say when you throw the stone at an angle theta with respect to the vertical, in both of the cases, what do you notice? This distance, which is your range, will be same in both the case. The horizontal range is same whether theta is the angle of projection with respect to horizontal or vertical. Fine. So it doesn't matter if you make this angle theta and throw the stone, or you make the angle theta with respect to y-axis also you throw the stone. In both the cases you will have the same range. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So thank you.